All right, Moneysocket. So I guess the story of the last 6 weeks or so is rebuilding things with the architectural model of like layers, and that's just a way to sort of separate the concerns out in the protocol. So I've talked about that in the previous videos, but yeah, so I built all the Python stuff, the relay and the terminus on the layered, but then the exercise was then reworking all the JavaScript to use the same style and to provide that as the library of like all the generic functions. And the reason, well, part of the reason why there's this layered architecture is we want to be able to define extensions. So in this case of the buyer and the seller app, I've implemented the extension as a layer on top of all the generic, amenities of, being able to request and pay bolt 11s and that kind of thing. Placed a new layer on top that has its own set of messages defined and its own set of behavior, but it can take advantage of everything that's underneath it. So the idea is, when you want to build an application, you grab the generic Moneysocket library, you npm install the Moneysocket library, and then you define your custom application behavior to negotiate over money to be able to buy and sell different things. And I'll go a little bit into the code after, but I might as well just start running the code so at least we know what we're talking about. So I have on the terminus here set up two accounts, so it's the same C Lightning instance. I'm just providing two different accounts. So this is the customer's wallet and this is the seller. But the customer is going to connect their generic wallet to the buyer app. So there, the balance gets forwarded upstream, and then the user has some control over the permissions of how many satoshis to expose and that kind of thing. So the final step is to connect the buyer to the seller. So they also need to connect over Moneysocket. So I can generate a beacon for that and get them connecting. So they do a handshake. However, it's not fully completed just because this is how I defined this extension protocol. So the Moneysocket connection's been made. All the connections to have the provider connect with the consumer and be able to do the basic stuff. That's all been done. But on the final layer, it's not quite finished yet. And the way I defined it is the seller actually needs to open the store before it is actually ready. So the act of opening the store finishes the final bit of the handshake, and now we're good to go to be able to start transacting between the buyer and the seller. So in the extension protocol, I've also defined when the store opens, it sends to the buyer a list of the things that can be bought, and I've defined that as three different things. There's a hello, there's a timestamp, and then the bullish and bearish opinion, and that's just to kind of show some slightly more complicated things of like, here's a menu of stuff that you might want to buy from me. So when I click the button, buyer requests from seller a bolt 11 to say, hey, I would like one of these items, give me a bolt 11. The seller provides the bolt 11. The buyer then, once it gets that bolt 11, it forwards it back through the web wallets back to the terminus to pay. Now, these are the same C Lightning instance, so it's just doing like a circular payment. But it still works. It's just easier to set it up that way. If I go bullish and click. So I got Spark running. That's why it's popping up when the Satoshis, and there's like a routing fee. So that's why it's slightly more. That defines the economic interaction between the buyer and the seller of the extension layer. So I've merged this code. I'll just briefly, and this is of course more dry than the actual seeing it working, but in the browser directory, so if you go into the JavaScript, so this Moneysocket directory, this is all the generic code. This defines all the basic layered architecture. So if you're writing your app, you're going to npm install Moneysocket or something like that, and you're going to get this directory. But then all the rest of the wallet and the opinion and buyer and seller. So the buyer is defined in this directory, and the seller likewise. And then I got a bunch of UI stuff that is just there to support the basics of what I'm doing there. But so in this Moneysocket directory, I've got kind of the code separated out. But the the layers are defined here. Like I got consumer layers, provider layers, rendezvous layers, transact layers, and then the WebSocket, which we've talked about. Also supporting like Bluetooth and WebRTC and whatever else. So like that WebSocket layer could be replaced with a different layer that connects slightly differently. So that's the idea there. But I just have WebSocket right now. But the person that's just npm installing this library, they're probably not going to touch any of that code. If they're just doing a wallet, like I have here, they'll probably be using these stack components. So this is like a class that stacks up these layers. So WebSocket, rendezvous, consumer, transact, and that provides all the services you need, which you can see in the source. And then that has the mirror image. The consumer has a mirror image of a provider, which is WebSocket, rendezvous, provider, transact. And there's provider and consumer transact. There's some differences there that are necessary. But so that's the generic library. But then when you want to go define an application, so the buyer, for example, so on the buyer stack, so rather than using the generic stack, the buyer is going to set up their own stack, which is basically the same stack, but they're going to add a buyer layer on top of it. And the buyer layer is something that's been defined here, which extends it inherits from the base class. So it looks like any of the other layers. It's just defining its specific behavior. And I have messages as well. So the messages that are exchanged inherit from the base class of the Moneysocket. So yeah, as you're writing code, you grab the base classes, you extend them in the way you want, and then you put your layer on top, and then define it however you want. So that's the architecture model that's coming together. The Python is, of course, the same concept. I haven't built these three applications. I've only built the relay and the terminus, and I'm going to expand on that. But yeah, I think hopefully that presents the vision of like how the apps will come together using something like Moneysocket. Now, to just change gears, because this is something that's on my mind as I'm building this. My weekend project. I work on Saturdays. I do some like Lightning Network other projects. So one of the things I built a little while ago is this jukebox. So it's Raspberry Pi node. It's got the blockchain. It's also got C Lightning on it. So if you press the buttons, it cycles through the invoices for the songs. If you pay the invoice, it cues the song and plays it through the speakers. There's an amplifier and in the speakers. And I'm actually rebuilding this to have a different chassis and like look different. So yeah, I'm in the process of rebuilding it to be nicer. This is kind of junky looking. I just want to kind of make it a little more presentable because it's sitting in a public place at a Bitcoin retail location. So people come up and they're confused. So I need to like do it better so people are less confused. But the reason I'm bringing it up here is so I'm thinking about, so in this menu system, this would be the jukebox, and this would be the person that wants to buy a song. So if I were to make this a much more fully fledged fully realized jukebox idea where you have like, a bar or a common location, just kind of thinking through the use case and how that would work is you'd want some sort of, I guess call it user interface to the jukebox that shows all the songs that have been queued. And that would give you some ability to either queue a new song or pay money to preempt a song. Or if you're leaving the bar, maybe you want to like unqueue your song and get your money back or something like that. And then so you have this whole bunch of smartphones that are tethered into the seller app, which would be like the jukebox. And then so there's the need to provide the jukebox, which is going to catch the payments, but also a user interface out to the patrons that are going to buy songs. And so, kind of thinking about what's the lowest friction UI, if you have a device like this sitting in a bar, and then your customers just have like a generic Moneysocket wallet, to make them install an app or go go to a website or whatever, and then tether their wallet to their app, and then tether that app to the jukebox or something. There's just too many UI steps. So kind of what I'm envisioning, as kind of a stretch goal for where this will go eventually, is so the customer walks up with their wallet, and they're going to tether it to the jukebox somehow, and then the act of scanning this and getting this, that via some mechanism, this will direct the Moneysocket wallet to a user interface. So either a website or some other way to get the wallet to then open a browser tab with everything already connected, such that they just get the buyer interface. So their wallet interface gets replaced with the buyer interface, such that they're now seeing the songs getting queued, and they have the ability to manipulate it, and that will modify their balance and that kind of thing. So I got a couple ideas, and this is probably this isn't what I'm going to work on next, but that's certainly one of the powerful things I'm starting to spot working on this is to really smooth all that user interface friction just based on these beacon notions, and then using the socket to have the buyer and seller start negotiating over things, and you can make that negotiation as complex as you want it to, if that's warranted. Okay, so 11 minutes. I got one final thing. This is kind of what I'm pretty sure I'm going to be working on next, is the next push, because I'm done with the JavaScript here for now, and kind of what I've been doing is leapfrogging between the Python and the JavaScript to kind of make sure that they're up to parity. So I want to kind of turn back to the JavaScript for a notion. So we've talked about the notion of a stable wallet, and that's that would be like a Moneysocket application that sits in front of the terminus, but it has its own sort of account database, but it works in fiat currencies. We have this ability to propagate the balances upstream in Satoshis, and that's instant. That's the advantage of a connected asynchronous protocol, is sending messages is free once the connection is established. In the same way, so if you have a price feed feeding into this app can be calculating the Satoshi conversion and can be propagating the equivalent Satoshis upstream to the wallet. And we can also propagate, say, yes, this is 1,000 Satoshis. However, the user believes these are Canadian dollars, or these are euros, or something like that. So in the user interface, rather than show Satoshis, show it as the currency that the user believes this is stable in. And then that can go all the way up to the buyer and the seller, such that rather than, in this case, oh crap. Okay. Yeah. Okay. Yeah, I didn't mean to close the store, but okay. So here we're showing prices in Satoshis. So it could be that the seller is trying to make money in Satoshis, so they're invoicing in Satoshis. But upstream, the user believes they have euros, and they're getting their balance displayed in euros. And then when this negotiation happens, the seller says, hey, I'm selling these things. Here's how many Satoshis it is. But we can then display that in the currency that the user prefers. And I think that makes sense. And then, likewise, if the seller is selling in US dollars and the buyer is in euros, the seller's UI will show US dollars and the buyer will be euros. And the fact that transaction gets negotiated and settled in Satoshis is just a background detail. So that's something I want to kind of get built into the Moneysocket stuff at an early stage. I'm passing around MSAT values, which are just integers going through the socket. But I want to kind of make that a more expanded class, such that, okay, here's the MSATs, but then an indication, oh, actually, this is intended to be stable in this other currency, and here's the conversion rate. And then every time it changes, it gets updated. So that's something, I think that's a reasonably straightforward Python application, but that's I think, my next push to kind of get, get the Python stuff, and then you'll have to propagate that again through the JavaScript, which I think is a less of an exotic task than rewriting the whole stack. But yeah, anyways, you got any comments or thoughts? Telegram, let me know. Happy to talk about any of this. So thanks for listening.